All right, so we just did an example of complex roots from Algebra 2. So now we're in pre-calc. So we're going to find the x-intercepts of the roots, or really the solutions. Really, we're going to solve this for 0 to find all of our x-intercepts, roots, or zeros. And some of them may be complex, some of them may not be complex. So let's take a look. This is going to be significantly harder than just x squared, because you can't just jump right to the quadratic formula. So I have the equation f of x equals x to the 6th minus 4x to the 4th plus 27x cubed minus 108x, and I want to know what the x-intercepts are. So what I'm going to do is I'm going to set this equal to 0. That part doesn't change. Just because the equation becomes more difficult, the concept of setting it equal to 0 to find the x-intercepts stays the same. So I have 0 equals x to the 6th minus 4x to the 4th plus 27x cubed minus 108x. Now, we're still going to use the same strategies as we've done before. We're going to look first to see if there's a GCF. If I can factor a GCF out, I want to do that. Then I'm going to look to see if I can factor. Now, the key is, if it's 3 terms, you can look to see if you can use the AC method, but with higher order degrees. If there's 4 terms, you can look to factor by grouping. If it doesn't factor, then we have another skill as well. All right, so let me look. I have 6x's here, 4x's here, 3x's here, and x here. So I have a GCF of an x, so I can take that out. But then I have x times x to the 5th minus 4x cubed plus 27x squared minus 108. All right, so now I'm going to try to factor by grouping, and I will tell you this does factor by grouping. Most of the ones where I'm going to ask you to solve a higher order one like this, for right now, you're going to be able to factor. So we're going to have 0 equals, I have my x, times, and I'm going to group my first 2 terms, x to the 5th minus 4x cubed plus 27x squared minus 108. And now I want to factor the GCF out of each group. So now I have 0 equals x times, well, I have an x cubed. That leaves me x squared minus 4 plus, well, 27 is the greatest common factor there, and that leaves me x squared minus 4. So to finish this factoring out, I've got x times x cubed plus 27 and x squared minus 4. All right. Well, I'm not fully factored yet. So far so good. I've got it down to this, but I see that this is the sum of cubes and this is the difference of squares. So I'm going to factor this to x times, well, my sum of cubes, so we have to do our signs the same, opposite always positive. So I know I'm going to start with the plus. I'm going to have x plus 3, x squared minus 3x plus 9. This is the factor of the sum of cubes. Then x plus 2, x minus 2, and this is going to be my factors of x squared minus 4. Okay, now I'm ready to find my x-intercepts now that I'm fully factored, because I want all complex solutions to this. So I'm going to take each one of these products and set it equal to 0. So I have x equals 0, x plus 3 equals 0. I have x squared minus 3x plus 9 equals 0. X plus 2 equals 0, and x minus 2 equals 0. Well, this one's already solved. Here, x equals negative 3. I'll come back to this one. X equals negative 2, and x equals 2. So far we have 1, 2, 3, 4 solutions. By the end, we should have 6, because my degree of the polynomial is going to tell me how many solutions I have, which is the highest exponent is 6. So by the time I'm done with all of my complex solutions, I should have 6 solutions. So I should get 2 more out of this, which, in fact, this is a square, so it says I should have at least 2 complex solutions. Rather, it's a real number or an a plus bi, where there's an imaginary component to it. So let's do this. So when I look at this 9, that doesn't factor. Quadratic formula time. So let's do my discriminant. So I'm going to do a negative 3 squared minus 4 times 1 times 9. This gives me 9 minus, 36, which gives me 27. All right, so I want to plug it into the quadratic formula, which is going to be negative negative 3, negative b, plus or minus the square root of 27 over 2 times my a. Well, the square root of 27 breaks down to 3 square root of 3. So we're going to clean this up, and we have 3 plus or minus, that's a negative 27. Whoopsie, this is a negative 27. So we're going to have 3 plus or minus, because of the negative I got an I, and the 27 breaks down, so I have 3i square root 3 all over 2. So there are your solutions. My x-intercepts, or my solutions to this equation, is going to be, let's see, let's put them in order. Negative 3, negative 2, 0, 2. There's 4 of them, and then here's the other 2. 3 plus or minus 1, 2, 3i square root 3 over 2. And they're all 6 of your solutions. 5 of these are actual where they cross the x-axis, and these 2 is going to have like a little curve where it does not cross the x-axis somewhere within this graph. All right, that wasn't terribly bad. It's just a whole lot of factoring. It's a lot of fun, really. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.